Hey guys, this is Jay Writer, and I thought I would share a website with you on where you can view some data. It's NASA saying that it's going to be near real-time data for comet ISON's approach, hopefully its perihelion and departure, that will be happening on November 28th, which is Thanksgiving Day. If you go to this website, cometison.gsfc.nasa.gov. You can go to this website, and I'm going to show you these cameras and essentially how this works. And it's really easy to follow along. Essentially, when you get to this website, they've got 12 cameras total that's going to be capturing ISON, and there's 4 for each stage. There's 2 ways you can do this. Obviously the cameras are going to be right here. There's 4 right here for the approach, the perihelion, and the departure. But you can also go right up here, and because I kind of think this site's going to be a little bit slow, to be honest with you, especially on Thanksgiving Day. Hopefully NASA's prepared for that, but I don't know. But either way, you can also go to the kiosks right here. In case you're having some slow loading issues or whatnot. If you go to the kiosks, you have the same exact cameras that are listed on the front page here are also on the tab. You got the 4 for each stage, the approach, the perihelion, and the departure. Let me show you what this camera looks like. Here's one of the cameras, and this is from the these are the SDO cameras. So I mean, these are pretty cool. So right here, obviously this is the sun, pretty clear cut. And what we're going to be getting is we're going to be getting some frames. They're going to be coming through, and again, NASA saying that they're going to be near real-time images. So you're going to have several frames where we're going to be able to see ISON actually coming through here, zipping through. And this is one of the cameras that's for the approach. And this is not a real-time image right now. This is back on November 6th, but this is essentially what you're going to be seeing when you go to these cameras. But these images will start coming in from the SDO cameras on around 12:45 p.m. and 1 p.m. Eastern Standard Time on Thanksgiving Day, which is November 28th. Again, these are the SDO cameras. So this is going to be pretty cool. I don't know if you remember the last time we saw something really neat like this, and I think this is going to be far more spectacular than what we saw with this other comet. But there was another comet, you might remember, C2011 W3, which is also known as Lovejoy. You probably are familiar with it by that name. That comet came through on 2011, and not only did it make perihelion, but it survived perihelion. And if you don't know what perihelion just simply means it's the turn around the sun. And essentially what it does, the comet approaches, and then it slingshots around the sun. Now, most comets that are considered sun divers, like ISON and Lovejoy, most comets don't make it. And Lovejoy is the largest comet on record that actually not only made perihelion, but it survived perihelion. But here's something interesting about Lovejoy. Lovejoy was very small compared to, let's say, ISON, even Comet Encke, Comet McNaught. Now again, Lovejoy was a sun diver, and it did survive, but it's relatively small. Comet Lovejoy was estimated to be at during its approach about 200 meters, which is about 650 give or take feet, and now NASA was just absolutely astounded when Lovejoy actually survived. They were absolutely positive that Lovejoy was not going to survive perihelion. And we saw something really remarkable. And if you haven't seen this, I suggest that you go to someplace like YouTube. NASA Goddard has a site set up on YouTube, and one of the more famous videos that they have on the NASA Goddard account for YouTube is Lovejoy approach. It disappears, and then everybody just thought that was the end of it. That it exploded, it broke up, and then the next thing you know, frames started coming through from the cameras where we saw Lovejoy shoot out on the other side of the sun, and it blew everybody away because no one expected for it to make perihelion and survive. And they realized it was so big. One of the things that happened, I'm pretty sure it was a Lovejoy. It may have been Encke, but I think it was Lovejoy. One of the things that happened is that when it hit when it grazed the sun, the tail completely detached and was still on the other side of the sun. So as Lovejoy shot the other way around it, and they were able to get a kind of a better idea of what they think Lovejoy's size was. And Lovejoy was they went from 200 meters and they upped it to about 500 meters, which is about 1,600 feet, and still relatively small. And I'll tell you why. ISON, now remember, ISON's a sun diver, like Lovejoy is, which means it's going to graze the sun, and it's going to attempt to make perihelion. And so far, it's surprising everybody with its survivability here. But another thing that is amazing about ISON is the sheer size of ISON. We have a kind of a well-known comet that's been around for quite a long time, and its name is Comet Encke, or 2P Encke, is its designated name. And Encke was 4.8 kilometers or 2.9 miles is what they say the size of Encke is. And as ISON was racing through the solar system, the scientists started guessing ISON was around 2.4 miles. And then all of a sudden, something interesting happened, and it wasn't really too surprising, but it was still very interesting to watch. ISON went through what we call outbursts, and what that means is it's pretty much a very sudden and violent brightening of the comet, and that usually tells us that it's going to break up. And now ISON is looking like it's intact, but there was something interesting that did occur with it. We saw an X flare from the sun, or scientists saw, I should say, an X flare hit. It came from the sun, it slammed into ISON, and it stripped away the coma and detached the tail. And when it stripped away the coma, we got a better idea of what the possible size of ISON could be. And it was around the time of McNaught that they kind of changed how they sized comets. And McNaught is classified, I don't think it was really the biggest comet on record, but it was classified at the time because of the way they were, and I might be wrong, if I'm incorrect, somebody can correct me in the comments. But around McNaught, because they had changed what they were considering how they measured size, McNaught was listed as like one of the top 3, if not mistaken, comets on record. And you know, McNaught hit or came around in 2007, and it was huge. McNaught was just ginormous. It had a 225 million kilometer tail that was stretching out from the nucleus of its comet, and it was anywhere from 6 to 12 miles wide, is what NASA is saying McNaught was back in 2007. Now we have ISON, and it looks like, remember, Encke is 4.8 kilometers or 2.9 miles, and then you have ISON that they started off saying it was about 2.4 miles, and then they upgraded it to now saying that it might be closer to 3 miles, and the reason why they're saying that is because we got a really good glimpse of ISON when that flare, that X flare, remarkably slammed into ISON and literally stripped the coma back. It was like like peeling an onion. It just stripped the coma right off. That layer that was on the nucleus just came off of it, and it detached the tail on top of it. So we had a really good glimpse of what size this comet really could be. And they went back and kind of did some figures, and now they're saying, well, you know, it may be closer to 3 miles. If that's the case, then that's going to make it larger than Encke. So this will be, if it makes perihelion, it would be the largest sun diver on record to survive perihelion. Now, with that said, we've got some astronomers that are saying that this is not correct. It is not 3 miles. We've got some scientists are claiming that it could be 4 times the size of what NASA is saying, that their figures are way too low. They're saying that it may be closer to 12 miles. If that's the case, and that's being just the nucleus, then this is going to be absolutely the largest comet that we may have on record. And I would be surprised if there's something that's going to come along that's going to try to take place number one with ISON, if ISON becomes that new record holder over Lovejoy for being the largest sun diver. Remember that survived perihelion. Remember, Lovejoy was only about 600 feet. The top figures would be 1,600 feet, and that's only because it survived perihelion, and NASA redid their numbers because of its survival with the sun. And now you've got ISON, and they're saying, well, look, we know for a fact that it could be anywhere at this point from 2.4 to 3 miles. That will be the largest sun diver to make it, and yeah, I mean, my God, that's going to be amazing if it's really if some of the astronomers are correct in saying that NASA's being way too low on this, and the figures are really closer to 12 miles. That's huge because McNaught was estimated at 6 to 12 miles, and it had a 225 million kilometer, 225 million kilometers tail on it. So we'll see. We'll see what's going on with that. But maybe just trying to put things in perspective. I pulled up some images here when I was doing this video, and I'm going to show you ISON. And this is I think this was taken in May, and I probably should have done something a little bit more recent, but I didn't. I was kind of in a hurry, decided to do these images at the last minute. But this is ISON, and this is the nucleus right here, this bright spot. This whole area right here is the coma, and right over here is the tail. And this is a very, very small, tiny portion of the tail. The tail on ISON is huge, and we still have not gotten any official numbers on how long this tail is. But I am willing to go on the record and say, hey, I may end up getting an egg on my face. I honestly think the tail is bigger than McNaught's tail, to be honest with you. Just by some of the images that I have seen come through, when you compare it to McNaught, it just doesn't make sense that it could be smaller as far as the tail goes. So now remember, that was ISON. So let me show you. Remember, this is the nucleus right here. Here's the coma. It's just huge. And here's the tail. And let me show you McNaught. Now, McNaught he was a big boy. We're just going to be honest with it. It was a big boy. And I think you're going to be able to see the difference in what I'm talking about. Here's the nucleus. This whole area right here is the nucleus. Here is the coma stretching out. And there's this ginormous tail. Remember, 225 million kilometers was the tail alone on this. And this, the comet itself, they're saying was anywhere from 6 to 12 miles wide. Remember, this has been McNaught back in 2007. This is another picture of the same image, but it's showing the difference in temperature here. Right here, this red hot spot. This is the nucleus, and one of the reasons why this is so bright is because it's so hot. Comets are nothing but ice. That's all it is. It's just a huge ball of ice. And then the stuff that's in its tail is just debris that is picked up along the way it's traveled through the solar system. So with that in mind, just kind of looking at this, remember, here is ISON right here. That's that little nucleus. And I say little, but he's big. This is a big comet. But look at it compared to McNaught. McNaught just was he was a mammoth of a comet. Very, very hot, was very, very fast comet. And then let me show you a little video image altogether here that I'm showing you, but compared to the other two. But this is Lovejoy right here, and there's, here's the little head right here. This is the tail. And it looks like that tail may be long, but it wasn't really relatively very long, to be honest with you. This was a pretty normal sized Lovejoy, or a comet, very interesting comet, but it was pretty proportionate. There was nothing unusually long or anything about the tail on here, at least that I can remember. I remember this was back in 2011 when it made perihelion, And essentially what Lovejoy did, and I'm pretty sure this was Lovejoy that did this, when Lovejoy made perihelion, it approached and then it whipped around the sun and it came out over here in this area somewhere. And the tail, this whole back section right here, completely detached. On one of the images of one of the cameras, you see the tail just lingering back over here. It slammed into the sun and got caught up and grazed it, and the tail just completely just got cut off from this comet and was way back over here in this area. And remember, the tail is it's nothing, it's full of debris. It's picking up all the junk in space, rock, the whole 9 yards, just all the junk. And so that tail is full of all kinds of just, space junk in it. And it had completely detached and was lingering over here. And I remember this picture so well. And the picture I'm talking about with the detached tail, because you saw Lovejoy over in this area, and he had a little head, and there was a little bit of a little bow shot where there was a little mini ISON tail that is attached to the comet there, and it was over here, and he had a little tail that kind of went off this way here, and in the middle was this lovely head, the head of the comet, and then the rest of the tail, the main part of this tail, was just been severed off completely with its encounter with the sun. That was really an amazing show. But talk about show, what's going to be really interesting, and one of the reasons why I'm crossing my fingers and hoping that it does that ISON makes perihelion, is because of the fact that if it does, we're going to have one heck of a show in December, and that's going to be for the United States, because the United States is going to have Lovejoy in view in all the month of ISON in view in all the month of December, and we're going to be able to see just some amazing stuff. ISON is expected that if it makes perihelion and it survives, we've had some scientists say that it's going to be about 15 times brighter than the moon. I kind of think that's a little high. We've had most scientists say that it's probably going to be around 10 times brighter, and I would agree with those numbers, just because, especially when the outburst happened with ISON, we saw a little bit of dimming, but I'm still kind of in the area that I think it may be about 10 if it makes it. And I am very, very truly hoping that it does make it, because this is something for the lifetime, or for the ages. In our lifetime, if you're alive and breathing today, then it will be absolutely accurate to say that you have never seen it. Saying that ISON quite possibly could be the comet of the century. And I made a comment in my previous video during a tutorial on stellarium that I believe that whether it survives or not, perihelion, I think that it has lived up to its name, just from the course that it's taken over the past year and what we've seen with it and all the data we've gotten. It's definitely in my books as being the comet. I'm sorry, not comet of the year, the comet of the century. Excuse me. But I can tell you something else, and you may not know this. 2013 has been absolutely the year of the comets. You may or may not know, but there are currently 10 comets in our solar system. That is very, very unusual. And it's very rare. And that's not, I'm not trying to imply anything by saying that. I am simply saying that it's rare to have very dynamically different comets of different orbits being in the same system at the same time. And right now, that's what we have going on. We have 10 comets in our solar system. Encke showed up in stereo. We expected Encke. We knew Encke was coming. And Encke showed up in, I think it was around November 21st or so, and it showed up on stereo A. Now, Encke has a 33-year orbit. What that means is that we don't see Encke except every 33 years. And then about a day or two later, we saw on the same stereo A, ISON trailing behind it, and showed up in stereo A, and they were in the same camera at the same time, so in the same general vicinity. They're about 25 million miles away apart from each other, but nonetheless, they're remarkable because they're showing up in the same stereo A. But that's just two out of 10 comets. We have a total of 10 comets in the solar system, and some of these comets are dating all the way back to the 15th century and beyond. We've got one comet that the last time we saw it was in the 17th century, or might be the 18th century. Then we have another comet that we haven't seen since the 15th century, and we know about that one really well because that was the one that the Chinese dynasty, and I can't remember the name of it. It might have been Huan, I believe it is, or something to that effect. My history is bad when it comes to that part, but I do know it was a Chinese dynasty that had observed that, and it's in the record books, and that was the one that a chunk of it from the tail. I don't know. I don't know if it was a chunk from the comet itself or if it was part of something that came out of the tail, but that was in recorded history because that part came into the ocean, and we had some tsunamis that came from that one. So that one's well recorded in the history of comets, and that one's back in our solar system. So we've got very dynamically different comets, and yet this happens to be the year that they're all converging in the same solar system at the same time. And ISON is just putting on a remarkable show, and it's a new comet. It has not been in our solar system before. However, NASA was talking about this yesterday and saying that ISON has been around forever, and that was pretty much what they implied. They said since pretty much the beginning of time, ISON has been traveling through the universe, but it's just now entering our solar system in 2013 and making its way towards our sun. And yet there are 9 other comets with very, very dynamically different orbits. 33 years for one. We have another that's around 2 to 3 years. We've got another that's from the 17th or 18th century. We've got another one's from the 15th century. We've got another that's a couple thousand years old. And they're all converging. This is the year where they all have converged into our solar system and are moving through our solar system. Really a remarkable, remarkable time to be watching our skies. And this is something for the record books. And this is something where you can say, I was a part of this. I was alive, during this a very interesting celestial event occurring in our lifetimes is happening right now. So, God bless you guys. Love you guys. Remember, November 28th, you can check out the SDO cameras beginning around 12:45 to 1 p.m. Eastern Standard Time is when the first images are coming through from the SDO cameras. It should be an amazing sight. And we're going to be able to see ISON. I think Encke will be missing that. I think Encke had made its perihelion already. I think it did it back just this past week. There was nothing really significant from it. It does it every 33 years. But ISON is something that it's really up in the air. We don't know what ISON's going to do. We don't know if it's going to survive this or not. And if it does survive it, what a heck of a show we're going to have in the month of December. And even into January, we're going to have some interesting things that we're going to be able to see up in the sky from ISON alone. And, let's not forget, just the skies are just amazing this year. We've got 10 comets in our solar system with very, very dynamically different orbits to them. And the amount of times that they actually show up in our solar system, very dynamically different. And yet here they are. They've all converged this year. 10 very significant comets. That this is definitely the year of the comets. And ISON, I do believe, is definitely could be classified as the comet of the century, regardless if it makes perihelion or not. I do believe that it's absolutely fine to say that it is the comet of the century. So again, God bless you guys. Love you guys. Take care. And keep your eyes on the skies.